We have now finalized the light chapter. Now we have electricity and electromagnetic. Okay, electricity and electromagnetic. All right. This is the 5th chapter. Here are the laws. Again, same thing. And yeah, this is the first subtitle. So just Bismillah, let's start. And we do our best for that. Electron charge. So an electron has a charge, all right? So this charge is equal to what? By magnitude, okay, regardless of the sign, 1.6 times 10 to the power negative 19. But it is electron, so you need to consider also the minus if the question just mentioned the minus or mention the positive in the options, okay? But mentioning only numbers without sign, it means the magnitude. He wants the magnitude of it. He knows that it is in the negative sign, okay? Yeah. So now, let's see this question. The charge of a flashlight with the number of excess electrons is, this is the excess electron, okay? And it's given here, the electron charge. So we need to calculate the charge, okay? Now, if you see here, it is, all of them are magnitude. There is no minus, there is no positive, okay? He wants the magnitude only, okay? Anyway, so what we need to do, very simple, isn't it? The charge that we need, charge, it will equals to the total number of the electrons, which is 4.8 times 10 to the power 10 times 1.6 times 10 to the power minus 19. Okay? See, this is the number of the excess electron, and this is the charge of one electron. Okay? So we multiply the charge of one electron for the multiple to get us the total charge. Okay? So as I do always, I will multiply the tens together. So 10 to the power 10 times 10 to the power minus 19. This will give me what? 10 to the power minus 9. Okay? And 4.8 times 1.6, it will be, if you multiply it, it will be what? 7.7 or 7 point something, yani 6 point something like this. Okay? So yeah, that's it. And the charge, it has to be in the column, yani, if the unit is required. So the answer is what? It is yes. It is, just go to here. It is not A. Yeah, it is B. Okay, is it clear, guys? How does we solve it? Clear? It's not clear, Yasmin? Okay. Okay, there is, I think it's clear. Okay, just again, here is what? This is the number of excess electrons. This is many electrons we have. 4.8 times 10 to the power 10. Billions and billions of electrons, okay? And we need to get the charge of that billions of electrons. How does to get that? We multiply by the charge of one electron. خلاص, if we multiply this charge of one electron by this multiple electrons, it means will give me the total charge of all of these electrons. That's the meaning of it. So 7.7 times 10 to the power minus 9, it is the total charge. Total charge. And 1.6 times 10 to the power minus 19, it is only the charge for one electron. Okay? Yes. Okay, that's great. Great. So now let's see question number 2. Calculate the charge of natural body when photons are added to it. So I think same principle. We have the total charge. See, total charge. All right. It is 4 electrons. Only we have here 4. Before, the last question, we have how many? 4.8 times 10 to the power 10. Okay. So many electrons. But here only 4. Yani, this is a very small number of electron times 1.6 times 10 minus 19. Okay, so directly nothing will multiply with 10, so we'll keep it as it is. Only we have 1.6 times 4. So this, what do you think? If we multiply it, 4 and 6, it will be 2.4 with 4 to be 6.4. So 6.4, isn't it? So what is that answer? Oh, directly it will be A. It's here 14. No, not A. Sorry, guys. Sorry, guys. I just say hurry up. No, it will be here. Sorry. You must say hurry up for this one. N1 minus 19. Okay. Now here, if you see, we consider here the negative sign. Okay. And here we have minus 19. All right. And we have this number. Okay. We consider minus, so we put the minus because it's considering here. Because the charge, it's minus. So it will be C. Okay. Clear, guys? Clear? Good. It's similar to the previous question. Yeah. Okay. Good. Very good. Awesome. Now, this is a third question for the same, I think, principle. The charge on a natural object when the number of lost electron is 4.8. Okay, same principle. خلاص, total charge. Total charge equals what? 4.8 times 10 to the power 5 times 1.6 times 10 to the power minus 19. Okay? So here, 10s with 10s, here is 19. So here will be times 10 to the power minus, what? Minus 14, huh? Okay. And 1.6 times 4.8 will be, let me just check. If it is 4, as we have done previously, it will be 6.4. So 0.8 will be okay, yeah, I think it will be 7 point something, 7.67, something like this. Anyway, yeah, here is the thing. Now let's see the answer. Yes, good job, Arwa. So we see here 7.7. Okay, yeah, it will be A. But if you notice here, we have also negative. Yani this, alhamdulillah, this question is somehow put you in the safe side. But suppose that you are given negative 7.7. What answer you will choose in this case, guys? What answer will you choose? Why positive? What's the reason we choose positive? Yes, good job. I know that you know this, but just to highlight, it's lost electron. Lost electrons mean we just take out electron from the object, so it will be in the positive. Okay, so this we're just changing. Yeah, good job, guys. So you are aware of that. So it is A. Clear, guys? Clear this principle or subtitle, whatever we can call it. Good, very good, nice. Now we have this. Okay. Coulomb's law. Okay. Coulomb's law, it is F equal K. It is this. Now, Coulomb's law, it means that if we have a charge A, and there is also another charge which is B, okay, we need just to know what is the forces acting between them. F, what's happening, okay, there. Maybe they are positive, negative, whatever, we will put the sign for sure. If it's negative, we'll put the sign here. Positive, we'll keep them positive. So this force will describe whether it's attraction or repulsion or whatever. Okay, so this is the force. Now for the K, it is a constant, and I think 9 times 10 to the power I think 9. Q are the charges, and the R, it is what? The distance. R, it is what? The distance. Okay, R is the distance. Clear, guys, this concept, Coulomb's law? Okay, I think clear. All right, now let's see this one. What do you think the answer here, guys? Well, I think this reminds you about something that we have done before, isn't it? If you know that the electric force exchange between two charges represented by the relationship, okay, same as we have discussed, the relationship, the distance between increase twice. The original, and it's similar to the one that we have engaged yesterday. Okay, which is E equal, you remember this? E equal P over 4 by R squared, huh? And we say that if we just double, making doubling, so same thing here, if we just write things here, K, Q, A, and Q, B, and there is R squared, so same thing here, يعني خلاص, because yesterday we say E, we focus only in 1 over R squared, same thing here, will be F equals 1 over R squared. Same thing, if we double it, so it will be 4. The force will be reduced by 4th. If we double the distance, يعني multiply by 2, the force will decrease by 4 times. Okay, so it will be A. Okay, clear, guys? Okay. Right. Oh, now we have direct application of the law itself. A 5 micro column positive charge is at 30 centimeter away from. Okay. Now this is, let's say, a QA, and this is the R, 30 centimeters away from, and this is a negative charge, huh? QB. Find the magnitude of the electric force between the two charges. So we need just to find what? We need to find the force. K is given 9 times 10 to the power 9. Okay. Okay. So this is the K. All right. Now, let's see just how to do it. F equals K times QA QB over the R squared. Okay. Now let's just substitute directly because already we have everything there. So it will be 9 times, this is the K, huh? Times 10 to the power 9, right? Times the QA, what is the QA? It is 5 micro, okay? Micro, how much, guys? How much equivalent to what? The micro. Just help me, please. 10 to the power what? Yes, it is -6. Thanks, Simon, for this. To be -6, okay? Times, here is we have a minus. -4 times 10 to the power -6 again, because it is micro. And this will be because here we have 30 something. So let's make R, let's mistake R. R, it is 30 something. So it is in meter, will be 0.3 meter. So if we convert it is in this way, 3 over 10 meter. Okay, so we'll put it here, 3 over 10, and this will be squared. Okay. So just let's do it here. It will be a little bit lengthy. I think, yeah, we have enough space there. So let's just do it. Let's just do this one. This now 3 over 10 square, I'll just make it as an arrow here. After squaring it, it will be 9 over 10, over 100. Okay, 9 over 100 will be, okay? So now just let's put it here again, 9. Let me just write it again to make things clear. -6 times -4 times 10 to the power -6. Okay, over 9 over 100. Now we will just try to simplify the parameters we have. Okay, yeah. Here we have a 9 and 9. خلاص, we cancel these two 9s. Okay, and I can bring this 100 here up. Okay, this will be, just rewrite it again now. Now, خلاص, 9, it will be like a 1. So 1 times 10 to the power 9, it is 10 to the power 9. So it will be like this. It will be 10 to the power 9 times 5 times 10 to the power -6 times -4 times 10 to the power -6 times 10 to the power, because here 100, it will be what? to be 2 to power 2. Okay, so just correct this one here. Let's correct it. Well, it will be 10 minus 6. Okay, minus 2n. Where is minus 2n? Have I write anything? Minus 2n. Okay, the answer. Sorry about that. Okay, Ayman, just keep it. We'll check it. I think yes, you're right. Either it's 20 or 2. Okay, so let's see now. If you cancel here the 10, now first of all, let's multiply 4 minus 4 with 5. It is what? Minus 20. Okay, you see, maybe it is like this. Then we multiply the 10. Now 10 to the power minus 6, then 10 to the power minus 6, 10 to the power minus 12. With 9, it will be 3. It will be 10 to the power minus 3 times 10 to the power 2, isn't it? So this will be what, guys? Here will be minus 20 times 10 to the power minus 1. So if this decimal point, we bring it there 1 times to just get rid of this 10 to the power minus 1. So it will be minus 2. Okay, خلاص minus 2. It will be minus 2 Newton. That's it. Yes, and you are right, Ayman, and you are right, Sayyid. Everyone just do it. It is D. Minus 2 Newton. Okay. Just see, Hayasek, does this question come often? Actually, if you mean that's the length of the question, because of the mathematics here, I think the concept is clear, isn't it, Haya? But the thing is that it is very lengthy, isn't it? This length, no. As you see now, before we have solved this very quick one, question number 4, for example. And if we see some question here, for example, 1 line, 2 line, okay. So yeah, okay. All right. Actually, there is no calculator. You mean, isn't there? Is no calculator. I'm not allowed the calculator. Okay. Yeah, just yeah, it's not allowed the calculator. So because yeah, this is what I'm telling. If you face easy question, try to solve them. Yani don't spend many time or so much time on an easy question. Okay, I mean conceptual question and so on. Okay, so that you will save time. All right. Okay, as you will practice, because this yani question not often coming. Yani the length of that question, you see. Not and maybe some of you just can expect the answer maybe from the beginning, but generally they are not coming oftenly. Okay, so don't worry. All right. Now, if you see how many questions we solve like this during these 5 days, 4 days, many questions. I mean little, not that much. Few questions we have solved them. Okay, very few of them like this. So don't worry about this. And also put this. I am doing this step by step. Yani maybe you can do this from 2 steps or 3 steps maximum. Okay. Big numbers, no, they are not big. Yani these are all 10s, and this is the way that I'm doing. I'm just making simple. Just focus on 10. Okay, and try to multiply the 10. Multiplying the 10, it's meaning that the summation of the power. Yani meaning that minus 6 plus minus 6. Okay, it is what? Minus 12. Plus 9, it will be minus 3. So I bring the 10 as it is, and I put the power as minus 3. This is summation. Okay? Nothing is big. And you multiply the 5 times. Okay? Don't expect that you will give like this number, 8 point, for example, 0, 6 times, for example, by square root of 3 and maybe even integration. And no, nothing is there. Don't worry. This I'm not, yani, will be given like this. Okay, so don't worry. Don't worry. Much important that just your mentality. And I advise that the day that before the exam, relax. Don't open anything. Okay, and this is from some. I did this many times. And okay, relax. do PlayStation and go outside, okay, just to relax. Okay, this is very, very important thing, because you know something, if you are not relaxed and you're trying to solve many questions at the last 2 days or on the last day, okay, then maybe you're not sleeping well, then you go to the exam, then because of that sleeping and so on, you'll not solve well. Okay, all right, so be careful about that. Anyway, electric field now. Yes, this electric field, يعني it means that the field that's generated by the, for example, electrons or positive charges, protons, whatever. Okay, there is an electric field. Okay, to be coming from positive to the negative, right? And it can be expressed mathematically by this: E equal F over Q. Okay, E equal F over Q. This is the force. You remember the force we have calculated in the column law? This is the F between the two charges, the force between two charges. And the Q, it is the charge for these particles, okay? And the E, it is what? It is measuring of the electric field, okay? So let's see the question here. Okay. What is the magnitude of the electrical force? So now here, we need the force F on an electron with a charge of, and as we know that this is the charge of the electron, okay, found in electric field, and this is the electric field. This is Newton over the column. Okay, this is electric field, which is E. Okay, we need F, and we know now E equal F over Q. Okay, so now, okay, now if you notice that F will be what? E times Q. So if we do it like this way, we substitute now, we have 200 times the Q, which is 1.6 times 10 to the power minus 19. If we make 200, for example, as 2 times 2, 10 to the power 2, this 200 equivalent to 2 times 10 to the power 2 times 1.6 minus 19, okay? So 10s with 10s, okay? And 2 with 1.6. 2 times 1.6, I think 3.2. And this will be 10 to the power what? Minus 17, huh? Newton. Okay, so the answer, yes, you're right, correct, guys. It will be, I think, C, yes, as shown here. 3.2 times 10 to the power minus 17, as we have solved. Okay, is it clear, guys? Direct application to find the force. Okay, very good.
Mr. I have a question.
Yes.
I'm not sure what does magnitude mean.
What?
I'm not sure what does magnitude mean.
Magnitude mean? You
Yes.
mean here? What is the magnitude?
Yeah.
The magnitude means the value of the electrical force. This is the meaning of it. Clear? Yeah,
Okay.
it means the value of the electrical force. يعني sometimes we have magnitude and also we have sign. If we say, for example, magnitude, sometimes يعني somehow we don't consider the sign. We need only the value. Okay? So this is how it is. Okay? I think it's clear.
Thank you, Mr.
You're welcome. All right. Now, question number 7. What do you think the answer? Electric field lines are imaginary, okay? And they are directed away from, all of you, mashallah, is saying B. Let's say go to the B. Positive to the negative. Yes, direct. يعني positive to negative. If you look at the other positive, no. No. This is also for sure no. Okay? So it is from positive, just remember this, to the negative, these lines. Okay, very good. Question number 7 is done. Okay. Now we have the electric potential difference. You know that we measure something called what is the voltage? If we ask about the voltage, okay, it is called in other terms electric potential difference. Okay, يعني you can imagine it as, this is for your information, if you can imagine it as if when you, this is in our real life, if we have a ball, just we lift it up for this distance, okay, so that will store energy inside the ball, okay, as you remember this law, okay, it is for the potential energy for lifting things, and this generated by the gravity, okay. Somehow there is a similarity somehow, okay, also there, because we have the difference between a reference that we put for the electric field and with the charge. This difference, okay, will make the charge storing an energy, okay, and we call this as the electric potential difference, okay. As we have greater potential difference, it means that storing more energy inside it, the charge, okay. So, and also this can be calculated by the work over the Q. So the work that is coming into the charge. We have a charge and there is a work, okay? This work applied onto the charge, okay? So this is the delta V, okay? So this is the terminology of it, okay? All right. So now, let's see here. If the potential difference, خلاص, we know that the potential, it is the V, which is calculating the voltage, was what? 2.5 volts, okay? What is the work done? You see, there is a work is applied to move what? To move this charge, okay? Which equals to 5 coulombs, right? So we need the work, okay? What is the work? And here is the Q. So we need to apply this, which is V equals W over the Q, all right? So our static, it is D. So let's just make sure we need just to find the work. So for sure the work will be, it is something like multiplication V times the Q. V, it is 2.5, isn't it? And the Q is simply 5. So it will be what? 12.5. 12.5 watt joule, okay? So you are telling me it is D, and it, yeah, it is 12.5, okay? So if you see like this question, it's very straightforward. Yeah, this is actually one line. It's not 3 lines. One line, okay? Answer. Clear, guys?